Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 16 to 20 of the June 2015 Geometry Common Core New York Regents exam. All right, let's take a look at problem 16. It reads, if triangle ABC is dilated by a scale factor of 3, which statement is true of the image triangle A prime, B prime, C prime? One thing you want to note is that angular measures are preserved under dilation, okay? So dilation is when you scale an original object to the image by a particular factor. In this case, is 3. Now, one warning you want to keep in mind is that it's very easy to misplace the placement of the scale factor. As you can see in the options, you have 3 all over the place. It is extremely easy to misplace it, so you want to be really careful when you are solving this problem. The steps we're going to follow are as follows. First of all, we are going to create a sample triangle ABC and give it side measures. Then we'll dilate that triangle by a factor of 3 in step 2. And then step 3, we're going to write down a list of statements using these points that we noted here about preservation of angles, but extension or dilation of sides by the scale factor. Okay? All right, so step 1, let's go ahead and sketch just a triangle ABC. So it doesn't really matter how we sketch it, so let's make it 2. Well, actually, we can do 3, 4, 5. Let's do a 3, 4, 5 triangle. So we have 1, 2, 3, 1, 2, 3, 4, and then 5. All right. So this is triangle ABC. Let's call this CAB. And the side measures are 3, 4, since it's a right triangle, a Pythagorean triple, 5. Now, what happens when I dilate this triangle by a factor of 3? All the side measures triple, right? So let me draw another triangle. I'm not going to draw it to scale because of space. So we're going to have another triangle that looks like this. If I scale it by a factor of 3, we're going to have triangle A prime, B prime, C prime. This is a 90-degree angle. Guess what? This side is going to become 15. This side becomes 12. This side becomes 9. How so? Multiply all the side measures by the scale factor of 3. Now, what happened to the angles? They remain unchanged, right? So that's what we spoke about earlier concerning preservation of angles under dilation. These two triangles are similar, and we remember that asimilarity theorem, that if you have two triangles with two corresponding sides that are congruent, then they are similar. Okay, so similarity means that the sides are in proportion and the angles are congruent. Okay, so now that we have this situation, we're done with step 1 and 2. Step 3, let's write a bunch of statements concerning how the measures of the sides and the angles of this triangle compare. Okay, all right, so let's talk about the angles first. What do we know about the angles? Concerning the angles, we know the following. We know that the measure of angle A is equal to the measure of angle A prime, corresponding angles. The measure of angle B is equal to what? The measure of angle B prime, corresponding angles. And then the same story applies to C. Measure of angle C is equal to the measure of angle C prime. All right? So the angles are the same. So if you take a look at what we just wrote, and you look at the options here, what can you say about statements 3 and 4? Are they true? Statement 3 and 4 are telling us that the angles are changed under dilation. That contradicts these 3 statements here. These 3 statements tells us that the angles are preserved. Remember we talked about that earlier? So what can we do here? We can eliminate options 4 and 3 because the angles remain the same. A prime is equal to A, not 3A. C prime is equal to angle C, not triple C prime equals C. All right? Now, one of these two have to be correct because we know that the sides undergo a dilation. Now, which of them is correct? This is where it gets tricky. You have to be really careful, okay? So let's write down our statements concerning how the sides are related, okay? So if you triple AB, what do you get? You get A prime, B prime. When you triple the original, you get the image, okay? So when you triple BC, you get B prime, C prime, okay? 4 times 3 is 12. And when you triple AC, you get A prime, C prime. All right, so which of these statements out of 1 and 2 shows that when you triple the object, the original side length, you get the image side length? Which one? Look at the first one. If you triple A prime, B prime, you get AB. No, that's wrong. Look at the second one. B prime, C prime is equal to 3 times BC. That's exactly what we have here. If you triple the original, BC, you get the image, B prime, C prime. So our answer is option number 2. This is a very easy problem, but it's extremely easy to get it wrong because of the misplacement of your scale factor. So always give yourself a visual so you can do well on problems like this during the Regents exam. All right, let's take a look at problem number 17. Problem 17 reads, Steve drew line segments ABCD, EFG, BF, and CF as shown in the diagram below. Scaling triangle BFC is formed. Question, which statement will allow Steve to prove that ABCD, the segment ABCD, is parallel to the segment EFG? Now, just some reminders before we solve this problem is that if you have two parallel lines cut by a transversal, we have two transversals here, CF and BF, alternate interior angles are congruent, okay? Same side interior angles are supplementary and corresponding angles are congruent. In this problem, we are just focusing on interior angles, all right? But out of the options, there is no talk of adding up to 180. So we're not looking at corresponding angles here because we don't have that. And we're not looking at supplementary angles here because the options doesn't ask anything about supplementary angles or angles adding up to 180. Our main focus in this problem is alternate interior angles being congruent, okay? Because all we have here is just congruency of angles, and we only have interior angles here. All right? Steps are as follows. First of all, we're going to list all the pairs of alternate interior angles, since that's what we're looking at. And then we'll go through the options here to see which is a match. Anyone that is a match, that is sufficient for us to conclude that segment ABCD is parallel to segment EFG. Okay? All right, so let's go ahead and list the pairs of alternate interior angles, which must be congruent in order to conclude the parallelity of these two lines. Now, what does alternate interior angle mean? Well, interior, basically, you're looking in between your two lines. Okay, the angles in here are your interior. Okay, any angles inside this region right here. Okay, so this entire interior region, that's your interior. Alternate just basically means on different sides of the transversal. So this angle and this angle, they're alternate, okay, because they're on different sides of the transversal. Okay, so with that in mind, let's list our alternate interior angles and then see which one is a match. Alternate interior angles. Now, just to make things easier, I'm just gonna use numbers, okay? It's easier to work with numbers. So angle ABF, let's call that angle 1. Now, do you see an angle that's alternate to this angle along this transversal BF? It's this angle right here, Okay, so let's call this angle 1 and let's call this angle 2. So this is angle 2. All right, and let's see. Another pair of alternate interior angles along BF. Let's see, BFE. All right, BFE, or let's call it EFB. EFB, let's call that angle 3. What's the alternate interior angle to this one along transversal BF? It's CBF. Okay, CBF, or we can call it FBC, whichever one. So let's just call it CBF. So this one right here is angle 4. So there goes our pair of alternate interior angles along transversal BF. Okay, now let's look at transversal CF. We have another two pairs of alternate interior angles. All right, so angle BCF, or we can call it FCB. Let's call that angle 5. Now, do you see the alternate interior angle to angle FCB? It's angle GFC or CFG. Let's just call it GFC. Okay, GFC. Let's call that angle 6. These two are alternate interior angles along transversal CF. Now, do you see the next pair of alternate interior angles? Angle DCF, or we can call it FCD. Let's call it DCF. Let's call this angle 7. Do you see the angle that's alternate interior angle to this? It's angle EFC. Okay, or you can call it CFE. We call this one DCF, so we can call this EFC. So this entire angle right here, combination of 2 and 3, this angle, let's call it angle 8. So this is an alternate interior angle to that angle. All right, so let's go ahead and list out pairs of alternate interior angles which must be congruent if these two segments are parallel to one another. Okay, so angle 1 and angle 2 are alternate interior angles. Angle 3 and angle 4 are alternate interior angles. Angle 5 and angle 6 are alternate interior angles. Angle 7 and angle 8 are alternate interior angles. Okay, so what we're going to do here is go through these options and see which one generates a match with these alternate interior pairs we have over here. Okay, so first one, CFG, that's angle 6. CFG, okay, and then FCB, FCB, that's angle 5. Are they alternate interior angles? Yes, they are. So in order for these two lines to be parallel, these two must be congruent. So our answer is option number 1. Well, how nice, the first one turns out to be the answer. But if you take a look at the rest, you can rest assured that none of them is going to match any of these, okay? So that's that. All right, let's take a look at problem 18. It reads, in the diagram below, segment CD is the image of AB after a dilation of a scale factor K with center E. Okay, so this is the AB, the longer one is the original, and this is the image. Okay, kind of shrunk the segment. Question, which ratio is equal to the scale factor K of the dilation? Now, one thing you want to note is that to get the scale factor K of a dilation, you divide the corresponding side of the image by the original side. Okay, so that's the formula for finding the scale factor K of a dilation. Now, the steps are as follows. We're going to extend a line from the point of dilation E to the endpoints of the original and image segments. Okay, and we're going to write down our formula for finding the scale factor and apply it to the sketch that we have. So let's go ahead and do that. So I'm going to go ahead and extend a line through here. There goes the dilation happening. Now you have to be really careful here. Some students might look at this and think, oh, this is the original, and this is the image. That's false, okay? So please be careful. Note that this segment right here, that's your original, all right? And on the dilation by fractional number, it actually shrunk it to DC. This is the image, all right? So dilation doesn't always mean increase in size. It could also mean a decrease in size. So keep that in mind. Okay, now with that in mind, we're going to move along to step 2, which is to write down the formula for finding the scale factor K of dilation. Okay, so the formula is as follows. K, scale factor K of dilation, is equal to the image side length divided by the corresponding object, not object, well, object original, same thing, divided by the corresponding original side length, corresponding for short original side length. All right, please preserve correspondence here. Okay, so there you go. Okay, now, so that's all we're going to be doing. With this formula, we can find a set of 3 ratios that can help us find K. What are the 3 ratios? Let's go ahead and do it. So this on this side right here, EC and EA are corresponding sides. So the original side length is EA. If you divide that by the corresponding side of the image, EC, you will get K. Okay, so this side and that side are corresponding sides. Now, you can also use the length of the segments. The length of segment, the original segment, AB, or let's call it BA, divided by the length of the image segment length, DC, will also give you the K for dilation. And then lastly, EB, the side length, the longest side length for the original, EB divided by what gives you K? Can you see what it is? This side right here is from the original. What's the corresponding side for the image? You see what it is? It's this one right here, ED. Those two, when you divide both of them together, you're going to get K. So EB divided by ED. So the question is, any of these ratios here that shows up on this in our options, that will be the correct answer. All right, so let's look at option 1, EC over EA. Oh, voila, there you go. EC over EA, that's a match. Okay, B over DC doesn't show up here. EB over ED doesn't show up anywhere there. So we can clearly see that this is a correct ratio that can help you find the K for dilation. Now, just another point to note before we move on is take a look at this one right here. This is a very good trap, okay? EA over EC is not the same as EC over EA. To avoid falling into this trap, it's always good to write down the formula. The image goes on top and the original goes on the bottom, all right? This is totally wrong. So always use your formula to guide the generation of your ratios, all right? Let's go ahead and move on. All right, let's take a look at problem number 19. It reads, a gallon of paint will cover approximately 450 square feet. An artist wants to paint all the outside surfaces of a cube measuring 12 feet on each edge. What is the least amount of gallons of paint he must buy to paint the cube? All right, so just a quick reminder, a cube has 6 faces and its surface area is 6 times the area of 1 square face. Okay, so you have a cube right here, 6 faces, top, bottom, left, right, front, and back. All the faces are of equal measure. So if you want to find the surface area, you find the area of one face and multiply it by 6, okay? Steps are as follows. We're going to sketch the figure. We already have it here. We'll write down the formula for the surface area of a cube and apply it to this situation. Then we're going to set up a proportion, okay? A proportion relating the gallon per square feet and the gallons per the surface area that we are looking for. After setting up our proportion, we're going to solve it for the unknown, namely the least number of gallons to paint the total surface area of this cube. Okay? All right, so now we have the sketch. Step 2, formula. What is the surface area of a cube? Surface area of a cube is what? Well, if this is S and this is S, the area of one face is S squared, but there are 6 faces: top, bottom, left, right, back, and forth, and the front. Okay? So there's 6 of them. So the surface area is 6 times the area of one face, 6S squared. Okay? Now, in this problem, what is the length of one edge? 12, right? So that means all the edges measure 12. Okay, so the surface area of this cube, let's just write it as A, is going to be 6 times 12 square. Okay, that will be the surface area. And if you do that with your calculator, you'll get 864 square feet. Okay, all right. So that's the surface area. Now we want to find out how much gallons can be used to paint this cube with side length 12. Okay, so we're done with step 1 and 2. Step 3, we're going to set up our proportions. Okay, so let's go ahead and do that. So what do we know? We know that for every gallon, for a gallon, that's 1, you have 450 square feet. So 1 gallon gives you 450 square feet. So how many gallons? Let's call it X, will give us 864 square feet. Okay, in this ratio, the numerator represents gallons and the denominator represents area. Okay, this ratio is based on the fact let's declare our variables. Let X equals the number of gallons for 864 square feet. Okay, there are different ways you can set up this ratio, but this will suffice. 1 gallon per 450 square feet, X gallons, which we do not know, for 864 square feet. So we have the proportional relationship here. So we're going to simply solve this ratio for X, and that will be our answer. Okay, so how do we get X by itself? Well, that's not too complicated. Use an algebra to isolate X. We'll just multiply by 864 square feet since it's been divided by X. So we'll do the opposite of division, which is multiplication. All right, so if you multiply both sides by 864, that cancels out. The units go out also. Square feet cancels out with square feet. So we have X is going to be, what is it going to be? 864 over 450 gallons. That's the remaining unit. Let's use our calculators to figure this out. So we have 864 divided by 450. Enter 1.92. Okay, so our answer is 1.92 gallons. So let's take a look at the options we have. We have 1 or 2. Which one do we pick? The answer is 1.92. Which one do we pick? 1 and 2. Do we round down or round up? It's asking for the least number of gallons. If you pick option 1, you pick 1 gallon. Are you going to have enough gallons to paint the entire cube? Absolutely not. But if you pick 2 gallons, then you're guaranteed to have enough gallons to paint the entire cube. You have some extras left, but that's fine. It's better than not having enough. So our answer is going to be option number 2 to guarantee that we have sufficient gallons of paint to paint the cube. Okay, so let's go ahead and write it down. X should be 2 gallons. All right, let's take a look at problem 20. It reads, in a circle all shown below, diameter AC is perpendicular to segment CD at point C, and chords AB, BC, AE, and CE are drawn. Question, what statement is not always true? Now, this problem is a little bit intense, but just pay close attention. You should be able to master the process, okay? Now, just 2 reminders or 2 things to note. First of all, if an angle is inscribed in a semicircle, it forms a right angle. Okay, so you see a semicircle here, the segment that goes through the center to the circumference of the circle. This is a semicircle. So any angle that's inscribed there is going to be a right angle. What is a right angle? 90 degrees, okay? 2, a tangent line to a circle is perpendicular to the radius at a point of tangency. Segment CD is a tangent line, okay? And it is perpendicular to the radius at this point of tangency here. We have another 90-degree situation, okay? All right, so what are the steps? So we'll label our angles numerically. I like to use numbers so that just for convenience reasons, so I can easily write a lot of statements. And then after enumerating our angles, we're going to use our circle theorems to establish relationship between any angles that we can relate with one another based on the theorems, okay? And then we'll see which of the statements match this. The options we have here, if we have a match, it should be eliminated because we're looking for which statement is not. Remember, not. We're not looking for the statements that are true. We're looking for the ones that are not always true. Okay? All right, so let's go ahead and enumerate our angles real quick. So I have angle, let's call this 1, angle 1, angle 2, angle 3. Let's see. Call this right here angle 4. Gets a little bit tricky here. Let's call this 5. And then let's call this 6. This one, 6. And then we can call the entire thing 7. From here to here, 7. Okay? Alright, so 5 plus 6, angle 5 plus angle 6 gives you angle 7. So let's start with the easy one, which is the whole idea of an angle being inscribed in a semicircle being a right angle. So angle AEC and angle ABC are inscribed in a semicircle. AC is the diameter, it splits the circle into 2 halves. Okay, so this entire piece is a semicircle. All right, semicircle because the circle is divided into half by the diameter. Okay, so let's keep that in mind. So what can we say? We can conclude that this angle here is 90 degrees. This angle also is 90 degrees. Okay, so let's go ahead and write down that remark. Oh, wait a minute. There's also another conclusion we can draw. Using the second points to note, a tangent line to the radius or diameter, they're collinear, is 90 degrees at the point of tangency. So this angle here, angle ACD, is also 90 degrees. Okay? So angle 3, 1, and 7 are 90 degrees. So let's go ahead and write that down. Measure of angle 1 is equal to measure of angle 3 and is equal to measure of angle 7, and they're all 90 degrees. Okay, so with that in mind, let's see if we can eliminate some statements here that are always true. So let's look for any pairs that relate 1, 3, 1, 7, or 3, 7. ACB, no. Option 2, ABC, ABC, and ACD. That is a true statement because ABC is angle 1, ACD is, what is ACD? ACD is angle 7, remember? Angle 1 and angle 7 are congruent, they're both 90 degrees. That's always true. So it should be eliminated. BAC, no. CBA, yes. CBA and AEC, absolutely. This is angle 1 and AEC is angle 3. They are both 90 degrees, they are congruent. That's always true. Eliminate it. Okay, so now we have 1 and 3. One of these is always true, one of them not always true. So let's see which one is always true. Okay, so now let's look at option 1 and 3. One of these is always true and one is not always true, okay? Now, I'm going to do this in two ways. I'm going to do it using a shortcut, and I will show you how to do it the long way, okay? So let's do the shortcut first. If you don't get it, hopefully you can get the longer way of doing it. All right, the shortcut just basically is based on the fact that if two angles are complementary to the same angle, they are both congruent. So if you look at triangle ABC, what you will notice is that angle 1 is 90 degrees. So if angle 1 is 90 degrees, angle 2 and 5 must add up to what? They must both add up to 90 because 90 plus 90 is 180, okay? So angle 2 is a complement to what? To angle 5. Okay? Now, if you take a look at angle ACD and BCD, based on the second point to note, we notice that this is 90 degrees. Okay? So what do we know about angle 5 and angle 6? They would add up to 90 degrees, so they're complementary angles. They're complements of each other also. Okay, so angle 6 is a complement to angle 5. Basically, they add up to 90 degrees. So if 2 is a complement to 5, they add up to 90, and 6 is a complement to the same angle, they add up to 90. It automatically follows that these two must be the same angle. Okay? So the conclusion here is that angle 2 is congruent. It follows that angle 2 is congruent to angle 6 since they're complements to the same angle, namely angle 5. Okay? So if angle 2 is congruent to angle 6, let's see which option is correct. BAC is congruent to DCB. So this statement is always true. That means our answer is option number 1. Okay, so that's just a shortcut using the whole idea of complementary angles. Now let's do it the long way using the triangle angle sine theorem and the other tangent theorem. Okay, so long way. Okay, there's nothing wrong with this. It helps you really understand what's going on. So let's take a look at triangle ABC. In triangle ABC, what we know is that measure of angle 2 plus measure of angle 5 plus measure of angle 1 is what? The sum of interior angles of a triangle is 180 degrees. Now, by substitution, we know that the measure of angle 1 is 90. So the measure of angle 2 plus the measure of angle 5 plus 90 degrees, the measure of angle 1, is equal to 180. Now we can subtract 90 degrees from both sides, and that yields the measure of angle 2 plus the measure of angle 5 equals 90 degrees. Okay, let's call this equation 1. We're going to be solving systems of equations here just like we did in Algebra 1. We're not solving it all the way, but we're going to end up with a statement. Okay, all right, so let's keep that in mind. Now, let's take a look at BCD and ACD. Okay, so what can we say there? Angle 5 plus angle 6 is equal to 90 degrees also, right? So let's go ahead and write that down. All right, so measure of angle 6 plus measure of angle 5 is equal to 90 degrees. Okay, now let's go ahead and multiply the second equation by -1. What we're going to do is we're going to subtract the first equation from the second equation. Okay, so we write the first equation, measure of angle 2 plus measure of angle 5 equals 90. And then negative measure of angle 6 minus measure of angle 5 is equal to -90. All right. All right, so we go ahead and combine both equations. Equations one, well, what we are actually doing is we are subtracting equation 2 from equation 1. All right, so combine them, and what does that yield? That gives us the measure of angle 2 minus the measure of angle 6. Measure of angle 5 and angle 5 cancel out. 90 minus 90 is 0. Now, what happens when you add measure of angle 6 to both sides of the equation? If you add the measure of angle 6 to both sides of the equation, you end up with the statement, measure of angle 2 is equal to the measure of angle 6, right? So that follows that angle 2 is congruent to angle 6. That's exactly what we talked about here. Go back to the triangle, the situation we're dealing with. So angle 2 is congruent to angle 6. So we can just mark it this one right here. It's congruent to that one right there. So that means that angle BAC is congruent to DCB. Okay, that is always true. So by elimination, the one that's not always true is option number 1. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial helpful to you, please give us a thumbs up. We'll appreciate your positive feedback. Do not forget to subscribe to our channel so you can get instant updates to the remainder of this review series. If you have any questions or comments, just include it in the comments section below, and we'll be glad to address it as soon as possible. Don't forget to take our interactive practice test to make sure that you're ready for the upcoming Regents exam. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.